Have you ever considered what drives the flow of water, whether it is moving through a pipe or seeping through the ground? It is all about energy, and understanding this energy helps us predict and manage water systems. Velocity head is a component of total hydraulic head that specifically quantifies the kinetic energy of the moving water, representing the height to which a column of water would rise due to its motion. The total hydraulic head, often simply called hydraulic head, is the sum of three distinct forms of energy per unit weight of fluid: pressure head, elevation head, and this kinetic energy component, the velocity head. This relationship is derived from the principles of fluid dynamics, particularly Bernoulli's equation, which states that for an incompressible inviscid fluid in steady flow, the sum of pressure energy, potential energy due to elevation, and kinetic energy due to velocity remains constant along a streamline. In practical terms, it means that as water moves, its energy can convert between these different forms. Velocity head is mathematically expressed as the square of the flow velocity divided by 2 times the acceleration due to gravity, which beautifully translates kinetic energy into an equivalent height. To practically use this concept, hydraulic engineers and hydrologists often calculate velocity head in scenarios where water is moving at significant speeds, such as in pipelines, open channels, or during flood events. For example, when designing a hydropower plant, accurately determining the velocity head helps optimize turbine efficiency. In groundwater hydrology, however, because groundwater typically moves very slowly, the velocity head is often considered negligible and is omitted from calculations of total hydraulic head, simplifying the analysis significantly. An interesting nuance is that while velocity head is theoretically always present in moving water, its practical significance varies immensely. In porous media, like an aquifer, the flow velocities are typically on the order of millimeters per day, making the velocity head minuscule compared to the pressure and elevation heads. Conversely, in a high-velocity jet from a fire hose, the velocity head becomes the dominant component, reflecting the powerful kinetic energy unleashed by the water. Understanding the role of velocity head within total hydraulic head allows us to correctly account for all forms of water energy, enabling us to make informed decisions for everything from urban water supply to irrigation systems, ensuring efficient and sustainable water management practices based on a complete energetic picture.
If you love learning about water, like, subscribe, and keep exploring with us.